Welcome back to Zito TechVerse. In this video, we're tackling the top 30 scenario-based DevOps interview questions. Instead of plain definitions, each one drops you into a real situation and asks how you'd respond. Let's begin. Here's our roadmap. We start with CI/CD and release scenarios, move into containers and Kubernetes, cover infrastructure and cloud, and finish with monitoring, incidents, and culture. 30 real-world situations in total. Section 1. CI/CD and release scenarios. Question 1. A developer's pull request keeps failing the CI build, but it works on their laptop. How do you investigate? Start with the CI logs to find the exact error. Then, compare the environments and reproduce the build in a clean container that matches the CI image. Finally, pin your versions to ensure consistency. Question 2. Your team deploys manually, and releases are slow and error-prone. How do you improve this? Introduce a CI/CD pipeline to automate builds, tests, and deployments. Use automated tests to catch issues early, and implement manual approval gates for production to maintain safety while removing manual toil. Question 3. A bad release reached production and broke checkout. How do you recover fast? Roll back first to restore the service before you start debugging. Once the site is stable, perform a blameless root cause analysis to address the process failure and prevent it from recurring. Question 4. Deployments cause brief downtime. How do you achieve zero downtime deploys? Use rolling, blue-green, or canary deployment strategies. Always include health checks so that traffic only hits ready instances, and ensure your database migrations are backward compatible. Question 5. Your pipeline takes 45 minutes. How do you speed it up? Measure your stages first. Then, cache your dependencies and Docker layers to avoid unnecessary work. Run independent test suites in parallel, and isolate slow end-to-end tests from your fast unit tests. Question 6. An API key was accidentally committed to the Git repo. What's your response? Rotate the secret immediately at the provider. Then, scrub the key from your Git history and force push. Prevent future leaks with automated secret scanning, and by using a proper secrets manager. Question 7. How do you support multiple environments without copy-pasting pipeline configs? Parameterize your pipeline, and use per-environment variables. Promote the same built artifact across all environments to ensure what you tested is what gets deployed. Section 2. Containers and Kubernetes scenarios. Question 8. A container runs fine locally but exits immediately in production. How do you debug it? Check the container logs and exit code. Ensure your main process is running in the foreground as PID1, and verify that all necessary environment variables and configuration files exist. Question 9. A pod is stuck in crash loop backoff. Walk through your troubleshooting. Describe the pod to see events and the last state. Check the logs, including those from the previous instance. Common issues include bad configuration, missing secrets, or failed health probes. Question 10. One pod is being killed under load. How do you resolve it? Confirm the status by describing the pod. Right-size your memory requests and limits to reflect actual usage. Investigate potential memory leaks, and add horizontal scaling to spread the load. Question 11. Your Docker images are huge and slow to pull. How do you shrink them? Use multi-stage builds to ship only final artifacts. Use a slim or distroless base image, and add a .docker-ignore file to exclude unnecessary files from your build context. Question 12. Two services need to talk, but one can't reach the other. First, verify the target service and its endpoints exist. From inside a client pod, test DNS resolution and confirm the correct port and namespace. Finally, check if a network policy is blocking the traffic. Question 13. Some pods fail to reschedule after a node failure. Describe the pending pod to find the scheduling reason. It's likely due to resource constraints, taints, or affinity rules. The fix is to add capacity using a cluster autoscaler or relax those constraints to allow placement on available nodes. Question 14. Need a risky change for only 10% of users? Use a canary deployment. Route a small subset of traffic to the new version, and monitor errors and latency. If metrics look good, scale up to 100%. If not, roll back instantly to limit the impact. Question 15. A critical CVE hits a third-party image. First, confirm if your usage actually exercises the vulnerable code. If so, update to a patched version or rebuild from a fixed base. Always integrate image scanning into your CI pipeline to catch these automatically in the future. Section 3. Infrastructure and cloud scenarios. Question 16. Manual console changes cause Terraform drift. Run a plan to identify the discrepancy. Decide whether to codify the change or revert the infrastructure to match your code. Never allow manual changes to become the silent source of truth. Change infrastructure through code and version control. Question 17. Your cloud bill doubled. Use cost management tools to break down expenses by service, tag, or region. Look for common culprits like idle resources, storage, or egress fees. Once identified, set up budgets and automated alerts to prevent future cost surprises. Question 18. 2 engineers corrupted the Terraform state simultaneously. Prevent this by using remote state with locking, such as S3 with a DynamoDB table. This prevents concurrent writes. Never store state files locally or in Git. Remote, locked state is essential for safe team collaboration. Question 19. You need to launch identical infrastructure in a new region quickly. Modularize your code and parameterize region-specific inputs. This allows you to stamp out the same configuration without manual work. Validate the plan in a sandbox before applying to ensure the new region matches your standards. Question 20. Your app must survive a full region outage. Deploy to multiple regions with data replication. Use global load balancing to failover traffic automatically. Choose your availability model based on your recovery objectives, and regularly run failover drills to prove your disaster recovery plan actually works. Question 21. How do you provide temporary cloud access securely? Use least privilege, time-bound roles instead of permanent keys. Implement just-in-time elevation that requires approval and expires automatically. Ensure everything is logged to an audit trail, so you have full visibility into who accessed what and when. Question 22. Your database instance is a single point of failure. Harden it by enabling multi-AZ deployment for automatic failover. Maintain automated backups and verify them with restore tests. Offload read traffic to replicas, and monitor replication lag to ensure your standby is ready when needed. Section 4. Monitoring, incidents, and culture. Question 23. Users report slow performance, but you have no metrics. Begin by instrumenting your services with logs, traces, and the 4 golden signals: latency, traffic, errors, and saturation. Dashboard these metrics so you can visualize the slowdown and identify exactly which component is causing the issue. Question 24. Your team has alert fatigue. Fix this by only alerting on symptoms that require human intervention. Tie alerts to service-level objectives rather than minor metric blips. Ruthlessly remove non-actionable alerts and route them effectively, ensuring only urgent issues page the team. Question 25. A major outage is happening right now. How do you run the incident? Assign an incident commander to coordinate the response. Focus on mitigating the issue and restoring service for users first. Keep stakeholders updated with regular status reports. Once service is back to normal, conduct a blameless postmortem to identify systemic improvements. Question 26. Dev and Ops blame each other when things break. How do you build a DevOps culture? Foster shared ownership by having developers operate the code they build. Replace finger-pointing with blameless postmortems that analyze processes rather than people. Align incentives through shared on-call responsibilities and shared performance goals. Question 27. Leadership asks how to measure if your DevOps practices are actually improving. What do you show them? Use the 4 DORA metrics. Show them your deployment frequency and lead time for changes, plus your change failure rate and mean time to restore. Track these as trends over time to demonstrate both increased speed and stability. Question 28. The same type of incident keeps recurring. How do you break the cycle? Dig deeper into the root cause using the 5 whys. Ensure post-mortem action items are assigned to owners and tracked to completion. Add automated tests or guards to prevent recurrence, and verify that the metrics confirm the issue is truly gone. Question 29. You're asked to improve security without slowing down developers. How do you approach this? Shift security left by automating scans in your CI/CD pipeline. Check code, dependencies, and containers, and only block the build for critical issues. Make the secure path the easiest one by providing pre-vetted templates and base images. Question 30. A teammate suggests a new tool for everything. How do you evaluate it? Start with the problem, not the tool. Pilot the solution in a small, time-boxed experiment to see if it delivers real results. Carefully weigh the learning curve, maintenance effort, and lock-in risk against the benefits before committing to a full adoption. That wraps up our top 30 DevOps scenarios. If these helped you prepare for your interviews, please like the video and subscribe to Zito TechVerse. Drop your toughest on-call stories in the comments for us to cover next. Good luck with your journey.